Alright, moving on to number 7. It's already got this beautiful table filled out for you. And it's kind of looking like it's not just adding 7 every time, maybe getting a little bit more. So it's probably got some sort of like percent increase. And if you want to know what to multiply by every time, you take 2 consecutive terms, do the second one, divide by the first, and you'll have your common ratio here. And I get 1.1. And you can test that out with any of the other 2 consecutive terms, and you actually get the same thing. And so this one has a common ratio of 1.1, and it is geometric. It's definitely not arithmetic because it's not adding the same number every time. It's geometric because it's multiplying by the same number every time. I'm going to write an explicit equation to define the nth term. And so we got a starting value, common ratio. We got the 2 things we need. F of n is equal to start value times common ratio to the n minus 1 power. And now we got that, we can try and figure out the temperature for the hot tub at hour 7. When we start counting, our first term in the sequence isn't with hour 1, it's with hour 0. And so hour 7 would be the 8th term in the sequence, because that's 1, 2, 3, 4, 5. You notice how it's the hour is always one less than the term in the sequence. So we're going to take 8 and put it in there. 8 minus 1 gives me 7. And so I got to do 7 times 1.1 to the 7th power to get what it is after 7 hours. So do that real quick. 1.1 to the 7th power. 7th, and then times it by 70, and that's going to give you 136.41, and this is all degrees in Fahrenheit. And there you go. 8 bacteria multiplying into 2 cells, and it start with 1 bacterium, and it doubles every hour. And so our initial value is 1, and our common ratio is going to be 2, because doubling, that's multiplying by 2 every time. So when we write our function, you just do f of n equals initial value times common ratio to the n minus 1 power. And really this 1 out here is a little bit redundant. You can really just write 2 to the n minus 1 power, because 1 times anything is the same thing. So how many bacteria will we have by the end of 1 day? I'm guessing 1 day means 24 hours. And so 24 hours would be the 25th term in the sequence, because if you start with 1, that's after 0 hours. And so we need to do that little shift. So we need to get the 25th term of the sequence. Sorry, 25 minus 1. And it's basically just 2 to the 24th, which you can plug in your calculator, and it's actually a fairly large number. To the 24th power to get, looks like 16,777,216 bacteria. Ta-da! Moving on to number 9, you inherit lands that started out 30,000 in 1960, increased by 5% per year. So we got a initial value of 30,000, that's a sub 1, and then my common ratio would be 100% plus that 5%, so 105% as a decimal, so 1.05. Oh, I need to write a function to represent the scenario, so f of n equals initial value times my common ratio to the n minus 1 power. And that's ready to go. Find the approximate current value of the land, assuming it is 2014. Well, we got to figure out real quick how many years that is. And that's a process of, well, 2014 minus 1960 is going to give you a little bit borrow, 54 years. Okay, and so we need to find out what is after 54 years. And so that's not going to be the 54th term, it'd be the 55th term of the sequence. Because at year 0, we have the first term of the sequence. So you have to make a little bit of an adjustment. So anyway, you plug in 55 into your little function here. You calculate it, and it's going to give you a beautiful number. As soon as I finish writing, I'll calculate it. 55 minus 1 is 54, so you got to do 1.05 raised to the 54th power, and then you got to times that by 30,000. And it is actually a fairly large number in comparison to what it used to be. It used to be 30,000. Now you're looking at 418,000 about 88 cents. It's oodles and oodles of money, but 5% a year for 54 years, that's a long time, and so you expect it to grow something like that. And then I'm just going to finish it up because we just got the 1. Buy a new computer at 21,000, so that's a sub 1. And then it decreases its value by 30% annually. So if you're trying to do a decrease of 30%, again, start with 100%, subtract the 30. That's a total of 70%. So every year you're timesing it by 70%. So your my common ratio is going to be 0.7. Alright, so I'm going to write my function f of n equals initial value 2100 times by your, man, I'm not writing real circle, times 0.7 to the n minus 1 power. And what's the value of the computer after 5 years? Well, we start counting the numbers in the sequence as 0, the 0 year being number 1, and so we need to find out the 6th term in the sequence. F of 6 is going to be 2100 times 0.7 to the 6 minus 1 power, that's 5. So do 0.7 raised to the 5th power times by 2100, and that computer is now worth a measly $352.95. I rounded up because I'm being generous. And so you're looking at that as your final answer there.